talk about log functions and their derivatives. The Bible in this section to know the following. The derivative of ln of anything is equal to, well, you put the anything in the denominator, and in the numerator, you put the derivative of the anything. For example, the derivative of ln of x squared. This is the anything. You put it in the bottom. You put the derivative of the anything on top. Calculus is done. Clean it up a bit. Kill off 1x in the top and 1x in the bottom. After all, the bottom is x times x, and you can kill off one of the x's. So the answer is 2 over x. The nice thing about logs is you never ever have to use a product rule or a quotient rule or even a power rule. Ever again. Suppose you have y equals ln over product. X plus 2 times 3x squared minus 4. Call this factor A and call that factor B. Now, of course, to take the derivative, you can put what we're taking ln of in the bottom, and then use the product rule to figure out what goes on top. But that's too complicated. We know that, we remember this rule, that ln of a product, like AB, is ln of A plus ln of B. So there's no more product. That is, this is ln of A plus ln of B. You have to know your rules. You have to. Now, to take the derivative of our sum, you do the derivative of each term. The derivative of this, well, I'm taking ln of x plus 2, put it in the bottom, put its derivative on top. Plus, I'm taking ln of this, put it in the denominator, put its derivative on top. And there's the answer. If you want, you can get common denominators. It will be x plus 2 times 3x squared minus 4. The x plus 2, top and bottom, gets multiplied by 3x squared minus 4. 3x squared minus 4. And the next factor, top and bottom, gets multiplied by x plus 2. Now, if you did use the first example, the first method, which I just erased, you would have had common denominators right away. Okay, we should know our 1 times table. That's 3x squared minus 4 plus 6x squared plus 12x. 6x squared plus 12x. And that numerator is going to be 3x squared plus 6x squared. Sounds like 9x squared plus a positive 12x minus 4. Minus that 4. And this is all over x plus 2 times 3x squared minus 4. The calculus was very, very simple. Take x plus 2, put it in the bottom, put the derivative on top. Take 3x squared minus 4, put it in the bottom, put the derivative on top. Logs are very friendly. There is no more product rule. There is no more quotient rule, which we'll see in a moment. And there's no more power rule. Remember, with logs, or ln of A over B, this is ln of A minus ln of B. So if you have a quotient, you don't have to use the quotient rule anymore. You use the subtraction rule. So if you're told that y is equal to ln of 3x squared over x plus 9, you should rewrite this as ln of the numerator minus ln of the denominator. Now taking the derivative of this is very, very straightforward. You take the derivative of ln of 3x squared, put 3x squared in the bottom, and its derivative on top, minus the derivative of ln of that, you put that in the bottom, its derivative on top. The calculus is over. Now it's all algebra. The common denominator will be 3x squared times x plus 9. Top and bottom here gets multiplied by x plus 9. And that's going to give us 6x squared plus 54x. 6x squared plus 54x minus, here we need to just multiply by 3x squared. That way both denominators equal what I've been using, this here. Okay, and 1 times 3x squared, I hope that's obvious, it's 3x squared. 6x squared minus 3x squared, well, that's 3x squared plus 54x. And this is all over 3x squared times x plus 9. We can factor out an x from the numerator. In fact, we can factor out a 3x from the numerator. 3x times x, that gives me 3x squared, plus 3 times 18 is 54, times x is 54x. And this is all over 3x squared times x plus 9. 3's cancel, 1x on the top or 1x on the bottom. So with 2 x's on the bottom, now there's only 1. The answer is x plus 18 over 3 times x plus 9 with a little typo because, it's just 3 cancel. X plus 18 over x times x plus 9. That product is now, that problem is now done. No quotient rule. No quotient rule. If you have ln of something to a power, the power can come down in front. So no more power rule. If you're asked to find the derivative of y equals ln of 3x squared plus 4x to the 9th power, one way of doing it is to take what I'm taking ln of, namely all of this, 3x squared plus 4x to the 9th, and put its derivative on top. That's one way. And I'll kill off 8 factors of 3x squared plus 4x on the top, and 8 from the bottom. Well, 8 from 9 is 1. And then you can factor this, and then there's your answer, which isn't unreasonable. But another way of doing it is to say, bring the 9 in front. You get 9 ln of 3x squared plus 4x. Y prime equals, it's 9 times ln of this. 9 times, the 9 just stays there for the right. You put what you take in the ln of in the bottom, and you put its derivative on top, and the calculus is done. I factor out a 2 from the top, so I get 18 times, I pulled out a 2, so that's 3x plus 2. And here's the answer. You never ever have to use any of those more advanced derivative rules. No product rule, no quotient rule, no general power rule. In fact, even if you don't have logs, you don't have to use the product rule anymore. If you have y is equal to, say, one function times another function, you don't have to use the product rule anymore. Why? Because you can take ln of both sides. You can take ln of both sides. I'm not touching the left side yet. On the right side, we have ln over product. Well, that's ln of f of x plus ln of g of x. This is my a, and that's my b. ln of ab is ln of a plus ln of b. Okay, let's take the derivative of the right side. The derivative of ln of anything, well, you put the anything in the bottom, and its derivative on top, plus the derivative of that. The derivative of ln of anything, you put the anything in the bottom, and its derivative on top. Left side, the derivative of ln of anything, you put the anything in the bottom, and the derivative on top. The derivative of y has always been y prime. Okay, now multiply both sides of the equation by y. Why is that? Because I just want y prime alone. The other side I'm going to multiply by y. But by the very top equation, that fg is just another way of writing y. F of x times g of x. When I distribute to the first, the g's cancel. I get, the s cancel. When you have fg times f prime over f, the s cancel. And you get g times f prime, or f times g. Plus, when you distribute here, you have fg times g prime over g. G's cancel. So you get f times g prime. Oh, what do you know? That's a product rule. That is a product rule. Now, what on earth am I saying? Okay, we won't do the algebra at the end, but if you have y is equal to 3x squared plus 4x minus 9, and you're multiplying this by 6x minus 5. You don't have to use the product rule anymore. You can take ln of the left side and then ln of the right side. But since the right side is a product, you get ln of the first factor plus ln of the second factor. Now taking the derivative of the right side, or even both sides, is straightforward. It's the derivative of this plus the derivative of that. Well, the derivative of this, the derivative of ln of this mess, well, I just put that on the bottom, and I put its derivative on top, plus the derivative of ln of that. I put that on the bottom, and its derivative on top. The left side, the derivative of this, well, I put this on the bottom, and its derivative on top. So now I just multiply both sides by y. The left side will just give me y prime. The right side, well, another way of writing y is 3x squared plus 4x minus 9 times, I ran out of space please, times 6x minus 5. And up to doing the algebra, there is your answer. There is your answer. No product rule, no anything. Y prime equals this mess over here. And no more product rule. Even if we don't have logs, You don't have logs? Introduce it. Now you have logs. Sometimes you might have a product and a power rule all in one. Suppose you have y is equal to, let's try this again. Suppose you have y is equal to ln of x squared times the square root of x cubed minus 9. Well, first you might realize that the square root is just to the 1/2 power. 1/2 power. Okay. So now you have ln of one thing times another thing. So that's ln of the first thing times, plus ln of the second factor. Now if you want, well, in the second term, you should bring the half down. And you take the derivative of that, well, you have 1/2. I put the x cubed minus 3 in the bottom, and I put its derivative on top. Now, in taking the derivative of ln of x squared, you can, if you choose, to put the 2 in the front. I choose to do that this time. The 2 stays on the top. The derivative of ln of x, well, you put x in the bottom and 1 on top. 2 times 1 is 2, so I won't even bother putting the 2 on the top. And I'll leave you with the algebra. You're in Calc 2 now. Let's do one more problem. An implicit problem. Instructions are to find dy dx. You have ln of xy plus 5x equals 30. Well, I see a product. I see ln of a product. I don't like products anymore. I just learned I don't ever have to do a product problem anymore. Product rule problem. ln of xy is ln of x plus ln of y. Plus 5x is equal to 30. The derivative of this, well, the derivative of ln of x, you put the x in the bottom, and the derivative of x goes on top, 1. Plus the derivative of ln of y goes on the bottom, the derivative of y goes on top. Everything's with respect to x. Plus the derivative of 5x is 5 equals the derivative of 30 is 0. So I want to solve for the term. I want to solve for y prime. But first I solve for the term that has y prime in it. The terms are separated by addition, subtraction, and equal signs. So I'm going to bring the 5 over and the 1 over x over to the other side. So positive y prime over y, that equals negative 5. Now, if you slip, you're realizing that both terms are negative, so you can factor out the negative. Plus 1 over x. Okay. And then all you do is you multiply the left side by y, because that gives you y prime. And you multiply the right side by y. And the final answer would be y prime is equal to negative 5 plus 1 over x times y. You want to get a common denominator, which will be x. You get 5x plus 1 times y. And there's your derivative. That's what dy dx.